Hey, everybody. I'm Nick Matthews. I'm a solutions architect at AWS. I work with our networking partners like F5, and today we're going to talk a little bit. We've got a bit of a mixed audience between some folks that know F5 and some people that know AWS. So we're going to start off with a brief review of some AWS networking basics, and then from there we'll jump into the F5 details and what they've got on AWS and what problem they're solving. So, at a high level, there's a couple of really big use cases that people use AWS for. And if you were at reInvent last week, that's probably been beat into your head, but it's worth repeating. The big difference here is scalability, especially for most workloads. If you really break it down, or only need to run at certain times, or they have peaks of sorts, especially with networking world, since we're the underlying kind of infrastructure for everything. We see that at different times you did different networking requirements. From a security perspective, F5 is big on security as well, but people have found out that they can run their applications more securely in AWS. So there's some of the folks, some of the analysts are out there talking about this, and then we've got customers like Capital One that came on the stage last year at reInvent and said they can run more securely on AWS. And we keep hearing this over and over again, and that's really important. Another cool thing is, if you're in the business of building data centers right now, and if you need to expand globally, either maybe you do a merger and acquisition, or you have different customers, or your business is growing, trying to build data centers across the world is very, very challenging. The good part is, Amazon's done that for you. So you can literally take your infrastructure that you've configured in AWS, click a couple buttons, and basically the abstraction layer that we've built is the same across the world. So you can go. Right now, as of today, we've got 15 regions, so that's pretty neat. As well as you only pay for what you use, right? So instead of getting your crystal ball out and figuring out, hey, what size appliance do I need? How much bandwidth am I going to need over the next 3 to 4 years? How many connections per second? All of those things, we don't have to guess that anymore. You can put out what you're going to use, and if it's small, it's too small, then you just upgrade to a bigger size. If you have some peaks, then you can either auto scale out, but basically it makes it much easier, so you don't have to predict what you're going to use, pay for what you use only. And since we operate at such a large scale, we get economies of scale as well on a number of things. And underlying all of these kind of use cases and benefits of the cloud is networking. If your networking isn't strong, none of your other stuff's right. So if you're doing big data, if you're doing analytics, if you're doing websites, you're doing mobile, no matter what you have, underneath all that's networking, and that's kind of the topic of the day, right? If you take a look at networking in AWS, there's a couple of core offerings that are important to understand. The first is Amazon's Virtual Private Cloud, or VPC, which we'll talk about in a little bit. AWS Direct Connect. AWS Direct Connect is the method that you can connect your existing WAN circuit or your existing data center network directly into AWS without having to use the internet. Amazon has our Elastic Load Balancing service, which we'll talk about, especially pertinent with our partner F5 here. And then Amazon Route 53, which is our managed DNS offering. So we deep dive a little bit on this. You'll see that from a high level, the first kind of thing that we'll talk about is regions. So for us, a region is a collection of data centers. So like I said, we've got 15 regions, and today we've got them in Ohio. That was our 14th region. It's pretty new. U.S. East 1, or Northern Virginia. We've got one in California, and then in Oregon as well. And today we actually just added Canada, so that's pretty exciting. Inside of each one of those geographical regions, we have AZs, or availability zones. Availability zones are roughly equivalent to a data center. Our AZs are often more than one data center. So availability zones, they don't share any power or internet connectivity or any other shared fault segmentation with any other AZ. So if you deploy an application into 2 availability zones, that's often good for doing active-active or backup and restore, any of those kinds of operations. And those all live within one region. A VPC, or virtual private cloud, will live in one region, and that's kind of your virtual data center of sorts. Inside that virtual private cloud, you can create a lot of traditional networking concepts. Like this, where you're subnetting your IP space, You can create routing tables that say maybe some prefixes should go to the internet versus some prefixes should go over VPN versus some that should go over my private circuit back on premise. And then we've got a couple security features that people use. So network ACLs are, they're pretty broad stroke, allows you to, for instance, if you have a set of IP addresses that you never want to be able to access your resources, or alternatively, only these IP addresses should ever access your resources. And then security groups. Security groups are kind of the workhorse for us in terms of security. Amazon Web Services has built a lot of our infrastructure to just be on the internet. And we use secure methodologies like SSH security, SSH without passwords, only using private and public key pairs to access the instance. So you can put that on the internet, and then the only thing is, securing in a lot of use cases is security group. So security groups is what allows you to block ports, allow applications to talk to each other even if they are on the internet, or they can also be in a private VPC with no internet connectivity. So if we dive deep a little bit more on Amazon VPC, Amazon VPC is effectively what allows you to create a separation. It's a logical separation at a networking level in AWS. So you can choose a region, create one or more VPCs in that region, and then start placing your infrastructure in each VPC. It's common for customers to have different business units or different applications, or often and most times, development and test will be in its own VPC versus production, which will be in a different VPC, to make sure that you don't do something dumb in development or test that could affect production. So it's effectively a network segmentation concept. You can use multiple availability zones inside a single VPC, and so it's very helpful for segmenting your applications. As well, you can do things like VPN. So we've got managed VPN that you can connect directly into your VPCs. You can, if you've got multiple VPCs, you can peer them with VPC peering. And if you want to connect them back on premise via your own networking circuits, you can use AWS Direct Connect for that. So if we dive deep a little bit on AWS Direct Connect, effectively what we do is for each region that we have, we've got a couple of locations that we call Direct Connect locations that allow you to come in and plug directly into one of our routers. So you come in at either 50, 100, 200, 300, 400, or 500 megabits per second on the low end. You could also do a 1 gig or 10 gig. And then from there, the world is kind of your oyster on how you want to connect. You can come in via your MPLS provider. So the vast majority of people's MPLS providers are also able to connect in via Direct Connect. So if you have a IPVPN or MPLS, and you want to do kind of a hub and spoke scenario where you want AWS to look like another virtual data center off your MPLS network, that's easily done. Alternatively, if you want to do something maybe more high speed, or if you don't have a large branch and campus environment, you just want to connect one data center into AWS. Maybe this is for the kind of the burst into the cloud use case, or a business continuity use case where you just want your servers to live on-prem and just spin up on AWS, in a case of failover. That's also fairly common for a first use case for folks. The benefit is, you get more predictable latency, more predictable performance. You're able to reduce costs as the outbound costs over Direct Connect are lower than they are over the internet. And so this is common for our larger customers that have a lot of data, or they care about the security and privacy of their connection. Elastic Load Balancing is Amazon's load balancing product. This comes in two forms. There's what we call the ELB, which is basically a layer 4, as well as can also do SSL decrypt and whatnot. And so ELB is kind of what we consider the classic Elastic Load Balancer. It runs in all availability zones. It can do cross-AZ load balancing, and it has fault tolerance, so that if ELB or an application fails, it's able to help fail over between those, as well as basic health checking. We've also added to this recently with the application load balancer, where we've got some basic layer 7 path-based routing, as well as WebSocket support. So we'll cover that a little bit more in depth later. Amazon Route 53 is our managed DNS service. So this allows you to create a public DNS entry that you can control the routing of the DNS entries. So you could do things like active passive, you could do latency-based routing, you could do geographical-based routing, so you could say only people from this country get this result. You can do a lot of complex routing, say I want 30% to go here, 20% to go here, the rest to go here, and I want those then to do health checks on these three things, and I want these to be health checked but not for these to be health checked, and you can do fairly complex routing with it. So it's good for multi-region failover if you want to do this. So it's the main way that we build services between regions. As well as you can also do it privately, so you can do it within your VPC if you want private DNS entries to resolve within a VPC, and that'd be called like a private hosted zone. So, if you want to learn more about these services, there's a lot of information out on our documentation. For instance, if you're more of a network engineer, I wrote a blog post called VPC for Network Engineers, and you can look that up on Google, and that might help as well. But from here, I think we'll focus more on some of the F5 use cases. And so as part of that, what we have is the AWS Marketplace. So the AWS Marketplace is a place where if you want to use the same tools and software that you're using in your data center, like F5, for application delivery, load balancing, firewall security, routing, VPN, whatnot, you can go out to the Marketplace and find these services. So from here, I'm going to introduce Robert from F5, who's going to dig a little bit more into the details.
Thanks very much, Nick. As Nick said, my name is Robert Haynes from F5 Networks. I'm a solution architect at F5, and I've been kicking around F5 for a while now. So I've seen us go from not having any virtual products to a really full-fledged set of virtual products available in AWS over the years. So I'm really excited to be here talking to you today. So just So, as Nick said, there's a mix of people on the call. Some of you, shockingly, might not know much about F5. So I guess the first thing I need to do is to give you a quick background on F5. I'm not sure why you should care, but we are a Seattle-based company. We're not far down the road from AWS Central. I think I should probably point out that we were here first. We're not just obviously based in Seattle. We're all over the US. Major development centers, obviously, in Seattle, Spokane, and San Jose, and we're pretty much global. We're in every geography. We have offices in EMEA, Asia Pac, Africa. So we're a worldwide company. There are some sort of company history facts that are relevant to anyone using us in AWS, but probably the most important thing is kind of the enterprise customer base. So we come at AWS from a position of being a enterprise vendor dealing with really big companies and fairly small companies as well, but in that sort of solid enterprise space, which may or may not sound like that useful if you're a born in the cloud AWS shop. But what it really means is that we're all about the support and service of the products. That's the thing we bring in terms of our heritage, is that because we're used to being in mission critical infrastructures. We're in front of some very large organizations, some very large applications for those organizations, and we come from a position where if we have a problem, then entire companies have a very serious problem. And then the things they build are not expected to fail, and they shoot chaos monkeys on site. So what it means for you in AWS is we've built a really solid, really well-tested product that's also backed by a large and highly skilled support organization that's geared to the needs of the most demanding customers. It's weird, but in the time at F5 I've been here, every company meeting, every review you ever go to, any customer, any review you have internally, it's almost like the customer sat numbers. You usually get as big a billing at least as any kind of financials, and that 9.2 customer sat rating, which we chase after almost religiously to improve the whole time, is something that's really central to the organization, and that's because of the heritage we have and the people we work with. But that's great because that carries over into Amazon as well and everywhere else we are. So what makes us different? So I guess the first thing to say is, yeah, we're the biggest and the best and the most respected organization in our sector. You can rate it by market share or position in the Gartner Magic Quadrant or customer sat numbers. And should you care? Well, maybe, but only if it brings you some benefits when you're in AWS. I don't think any amount of history awards or analyst recommendations really count for much if they don't bring you some tangible benefits. But what they do bring you is a way to help minimize the risk when you move applications into the AWS cloud. And why is that? Because we've got a ton of customers that are doing just that. And that scale of customers, that customer base, and the number of those that are now migrating into AWS. I don't know if many people on the call were at the at reInvent last week. I definitely got the feeling, which is not a very good scientific term, but I definitely got the impression from going around the hall and talking to our customers and going to sessions and listening to the whole thing, that this is the time that more and more enterprises are starting to move mainstream applications into AWS. We're certainly seeing that with our customer base. I certainly saw that with the number of people I spoke to last week doing just that. And that's good because we have a lot of enterprise customers, and therefore we see a lot of people start to migrate, and we know the pitfalls, we know what works, we know what doesn't work, we have a services team that are set up to help people. It also means that for those of you that are F5 customers, that you'll be able to potentially apply exactly the same application delivery and security policies that you use in the data center in AWS. Actually, if somebody came up to me, and I can't verify this to be true, I was just told this by a customer, so that what they've been able to do is to take a big IP instance in AWS and a big IP instance in their data center, and we have a configuration synchronization tool that we use to keep two HA pairs in sync. And what they've done is they've actually used that to sync their configuration from their on-premises data center into AWS between our two devices. And they'll probably have to tweak it a bit, but the bulk of their configuration, all the security policies, all the application delivery policies, all the clever high-value services for which we're known, we're able to just copy straight into AWS. The other great thing we have is just the breadth of services, and I'll go through those in a minute. But the breadth of services the platform offer is quite spectacular in terms of how much you can consolidate into a single instance. And the nice thing is these aren't checkbox features. We don't do features to suit RFPs. All the features we make they can go head to head with anything else out there. So our network firewall, or our application layer firewall, or our layer 7 DDoS mitigation, or our DNS services, then they all work and they can all be consolidated into a small number of platforms. So what does the Big IP Virtual Edition give you? So it's the same Big IP platform that you may have used before. And if you haven't used a Big IP platform, well, apart from shame on you, then the platform we provide is available in hardware, which I obviously won't talk about much today, given the call that we're on, and as a virtual edition in the AWS marketplace. What does it do is a pretty important question. I mean, the short answer is lots, but I've got you trapped on a webinar, so you do get the slightly longer answer. I mean, essentially the platform acts as an intelligent, service-rich, programmable proxy. So what that means is that client connections from web browsers, phone applications, trucks, cars, bathrooms, fridges will connect to us. We will terminate those connections, and then we will either reuse existing connections or make new connections to the back end. And that creates this logical gap, this virtualization layer, this sort of logical virtualization layer between client and server or service at the back end, and we virtualize that application. And in that gap is where we can add all of our features and do all the really useful things for you. Things like intelligent traffic management, deciding where to route some traffic based on a wide range of factors, not just a single thing. Where's the traffic coming from, because we have a full geographical IP address database, what the connection speed is like, what's going on at the back end, what's going on the front end, what the device is. We can look at the protocol, not just HTTP, but we can also do a wide range of protocols to see what's inside the request. And we can look at the response as well. And obviously we can encrypt and decrypt as needed. And then we can route, modify, or block the traffic, and even respond to the client as if we were a web server. We can serve sorry pages in maintenance cases if we need to, or any other page you want. This visibility and power means we can offer both network and application layer security. So we can provide basic network security. It's not something you're going to use a ton of in an AWS environment, because you have obviously your ACL capability, multiple ACL capabilities in AWS. But we can add an application security layer which is really powerful and really flexible. Even down to doing things like injecting JavaScript to look for signs of human interaction, like mouse clicks and keyboard strokes. So we can protect your applications from screen scraping. The other thing we can do is provide authentication offload. We have a full remote access VPN and authentication solution. So we can act as obviously a VPN endpoint. Again, you would probably use the Amazon services for that, but we also act as a really powerful authentication tool. So again, we can provide context-based authentication. So certain users from certain devices, from certain regions at a time of day, can have to jump through some more hoops to get into the application. And then we can provide single sign-on into that application as well. We can act as a SAML service provider and a SAML IDP. So it's a really long list of tools you have at your availability. The other cool thing is it's all programmable. So last week at AWS we spent a lot of time talking to people about the programmability features of the platform. And actually it's the programmability features which breed the love to a certain extent. This week I've been at Gartner Data Center, which is a much more staid and stodgy conference compared to the excitement of reInvent. But the number of people that have put F5 into virtual and physical environments for the functions and features that we provided kind of out of the box. But the reason we've stayed there is because we're in that 3 in the morning. Security vulnerability gets announced, or problem with the application behavior, or something strange and unusual that you need to do, then we are there because we are programmable. And we can program the data plane in terms of we can give you tools to alter the traffic as it passes in and out of our device. And that can save you a ton of time and effort in solving little annoying problems, but it also can give you like a really powerful protection against big security vulnerabilities while you fix things at the back end. We'll also be able to be programmed at the control plane, and we'll talk a little bit about things like CFTs and that sort of. But we can also program the control plane as well. So we have the ability via some of our scripting and our language capabilities to talk back to the AWS environment. So we can talk using the AWS Java SDK, and we can make AWS configuration changes based on traffic passing through the device. So you can do all sorts of really exciting and interesting configurations with that. So moving on, and this is great, but I mean, it's all fun. We all love playing with the toys. We all love having all this power at our fingertips. But if it doesn't do anything for the application or the user experience, then what does that mean? It's not really useful. Apart from we get to have lots of fun toys to play with. Essentially, this is the tagline that just won't die, and I've seen people try to kill it a number of times. But secure, fast, and available, admittedly in a slightly different order on this slide, is a thing that we've been saying forever. And I guess at some point when your applications don't need to be secure, fast, and available, then maybe there'll be no place for F5. But I don't see any need for any less speed, any less security, or any less availability anytime soon. And so we complement and augment the other things you're out there to make your application work well and stay working. But things like in fast, let's just pick on fast as a good starting point. So we have because we're a TCP proxy, so we're a full TCP proxy. That means your connections at the back end can have a completely different TCP profile to the ones at the front end. Now that sounds like really low level, really dull. Some might say that aren't network engineers, but the thing is, it can make a huge difference. It can make a massive difference. The amount of throughput and responsiveness you can get by having a well-tuned TCP stack at the front end and a TCP stack that's tuned for data center operations at the back end is quite dramatic. We have seen, 25% performance improvement, certainly when you're serving over congested radio networks, just by having the right TCP profile, which is a super easy thing to do on F5. You don't have to be a TCP guru. You don't have to understand what window sizes and MSS and congestion algorithms are. You just pick the TCP profile that's most akin to your client. So I have the system do it for you as part of some scripting. So that means that we can be sort of super fast. We can make applications go faster. We can also offer an HTTP2 gateway. Now I know that ALB now does HTTP2. What we are is a full gateway. So if you have an HTTP 1.1 application running in the background, we can present that as HTTP 2. And depending on the application type and what the profile looks like, how many objects there are on a page, that can make a massive difference. It can make an absolutely huge difference to the performance of the site. That's easily in some instances another 10 to 15 to 20% performance improvement through HTTP2, especially if you have lots of small objects. There's I can do another whole webinar on HTTP2, but it's amazing the difference it makes. And you don't have to adopt HTTP2 at the back end right now. You can use this to front the front end. So that's a couple of ways really, and these things are so easy. So easy to set. A single API call, single setting in a template, a single GUI click if you're still doing things in the GUI. The other thing obviously we do is keep your applications available. Now AWS does a fantastic job of keeping their infrastructure up and running. In fact, I was scratching my head at reInvent last week about how AWS managed to have this amazing culture and practice of innovation. Anyone that's followed the availability of services from AWS over the last few years can't be anything but impressed with what they bring out and the speed at which they launch it. And yet they don't seem to have, stability problems, particularly with any of these things. So it's amazing how, what a solid platform you get. And in fairness, I have built lots of solid platforms in data centers too, but it usually tends to be the application that goes wrong. Most failures I've been involved in have been application layer failures. So our ability to health check applications really carefully, not just that the server is running, not just that it's pinging, not just that it's responding to a basic HTTP request with a 200 OK or whatever, not that it's just is to have really good health checking of those application nodes and be really sure that they're absolutely working. And that means we can also cover, we can do fancy, clever HTTP2, HTTP request checking. We'll also cover things like we can make SQL requests against a variety of databases and check that we get the right number of rows and columns back. So if you want to make sure your database is really working correctly, you can set up like a test table, give it a right number of rows, and we can do health checks against that. We can health check against things like mail servers, SIP servers, any kind of TCP response we can check against. So we can really make sure that your application nodes are behaving as they should be. And obviously, if they're not behaving correctly, we can stop sending traffic there and let you know that they're not working. So super powerful, interesting way. I was thinking that we could do things like, if we needed to redeploy nodes based on them not working or failing health checks, probably via the API and the scripting language we can do that for you. So if we notice a node isn't working, we could either alert and potentially, I haven't tried this yet, but it seems possible to my Thursday morning brain that we could actually fire an API call to redeploy those from a template. Finally, obviously, we keep these things secure. Security is a huge issue for nearly everybody. I haven't last week I didn't have any conversations that didn't generally involve some kind of security aspect. So obviously we provide really good SSL processing. We can decrypt and re-encrypt at our layer, and this used to be super important for CPU solutions. People with server offload was really important, and everyone loved SSL decryption for that. And now we're all working potentially on the same CPU in a virtual environment. So you may think, well, why do I even need to worry? Why do I want to worry about doing SSL decryption anywhere other than on my server? It's safer to take SSL all the way through to my back-end server. That makes the most amount of sense. And that there's you can make that argument. I think the most important thing for SSL nowadays is visibility. So obviously you can't really protect yourselves against stuff you don't see. And if you're going to wait till your traffic gets all the way down to the server before you decrypt it and see what's hiding inside there, you may or may not have a problem there. So the ability to decrypt SSL and then be able to do inspection on that traffic and then potentially re-encrypt it if you need to is huge. And so therefore you need a device that's powerfully configured and designed to process SSL well, and then to be able to do useful things with that data when you get it out. So we have great SSL capabilities. We obviously have a network firewall that can go beyond simple things like the source and destination. We have geographic capability. We can take threat intelligence feeds in to look at reputation. We have the web application firewall, which is extremely well featured and is now potentially deployable using CFT for basic policies. So you can get an application firewall up and running really easily, and then take it from there and put any additional sort of features you want on. If you want to be looking at inspecting outbound responses for credit card numbers or social security IDs or other sensitive patterns for your geography, we have all that capability. So we have full DLP capabilities, full web scraping capabilities. We have layer 7 DDoS detection and mitigation. So if we see latency suddenly increasing on one slide, one page, one URL, there's sudden increase in connections, sudden increase in latency. We track that over time. We notice that, and we can start blocking people trying to get into that page, especially if it's coming time and time again from the same response, as well as all the signature-based stuff you'd expect. So really powerful set of tools, including authentication as well, to protect your applications in AWS. So at the end of the day, we have to work. All this is great. It has to work well with AWS. We have to work in this environment. Increasingly, it doesn't matter how great your product is, how fantastic the features are, how epically brilliant the support personnel are, and how wonderfully eloquent your marketing team is. If the thing cannot be deployed using the tools and the automation techniques that you've decided to use in your environment, then it's a non-starter. People no longer buy best of breed things necessarily. They buy great products that fit into their deployment landscape, and we're completely aware of that. So we're working really hard to make sure that that we can be deployed in the kind of ways that you want to deploy. So we're working with the likes of Ansible, Puppet, and Chef. We're providing CloudFormation templates to enable you to download them, and we're making sure that we're flexible. We can tie into the rest of the AWS ecosystem. So I'm going to answer this question before anyone asks it, because I think it's one that comes up. So when should you use F5 BIP? There are a lot of great services in AWS, including things like ELB and ALB. Why would I use F5, which is essentially has the same features as ALB, and when and instead of that? Well, I mean, there are a couple of, probably 2 or 3 really good reasons if they fit your environment. Okay, so the first thing is if you need functionality that's just not there. We've been doing this for a long time. We have an enormous number of features. Very, very rarely do we find something we just can't do. I always say that if you can't do it at the application delivery layer with F5, then it probably can't be done, because pretty much nobody has that range of features. So if you need to cover different protocol types, if you need to cover things that just aren't included, that are beyond the basic, then that's a time when you're going to want to use F5. When you want to write code, that programs the application traffic, the infrastructure, or the network at this programmable proxy layer between your back-end services and your front-end client, then this is the time that we give you a place where you can write simple code to do really powerful things, which is great if you need to write things that see the totality of the traffic. Very few other places that you can run code, see all of the traffic in both directions, and can do things based not just on one client instance or one server instance, but across the totality of that traffic. And finally, a thing we're finding a lot is people want simplicity. I've noticed this last week at reInvent and this week at Gartner Data Center. Simplicity is becoming king. And so it can be very simple if you are going to be continuing to run an on-premises and an AWS environment. And most of you are for a number of years, unless you're lucky enough to be able to kind of, move the whole lot, or you're starting from scratch in the cloud. The reality of your life is that there'll be, some stuff lying around until you finish migrations, or until you establish the mix of hybrid cloud that suits you. So the ability to deploy the same policies, use the same tools in on-prem and in other environments as well as in AWS can make your whole kind of management and your operations much simpler. The other question I'm going to answer before it's asked is how we work for high availability and how we work for scaling. So again, we'll break this down into three. I think my brain only works in threes. So we'll just go through them. So we're designed for high availability. We've worked in a high availability for pretty much forever. We've always been high availability, and in the data center we're commonly offering sub-second failover between devices, because that's what people expect from an enterprise class in the data path device. We offer the same kind of features in AWS. Obviously the way it works is slightly different, but essentially the way we've been designed to work is with devices heart beating between them and detecting when one's gone away. We scale across. I've drawn a pair of devices here, but we can potentially scale beyond pairs of devices. In AWS, obviously, you can run us, one in each availability zone within your VPC. That gives you a ton of protection. And if something goes wrong and we lose a big IP instance, we will remap the front-end elastic IP from one device to another. So we keep services up and running. We do that by obviously talking to AWS infrastructure using API calls to make it happen. One of the cool things you get with Amazon is auto scalability. It's one of the features you should definitely be trying to use if you have that variable workload, because you only need to pay for your servers when they're up and running, which is great. Obviously, if you're going to site your servers behind a big IP and we're doing useful, security application delivery services for you, we need to be aware that when you're adding services into that environment, and we're completely auto scale aware. There's a couple of different ways to do it. There's a really interesting article on Dev Central, which is our community-driven site where we provide a lot of technical information around more advanced configurations and programmability. devcentral.f5.com. If you just Google Dev Central, you'll find it. Where we explain a couple of different ways that we can hook in for auto scale. That means we can detect things behind us, essentially auto scaling, but we can also be auto scaled as well. So we can do the same way you can auto scale your server resources. You can auto scale your F5 big IP resources using CloudFormation templates. All of our CFTs, by the way, are available on GitHub. Again, look for F5 on GitHub. You'll find an AWS repository there. We will move some of our CFTs into full support. So at the moment they're kind of community support based. We will be supporting a selection of them with full F5 24/7, 365 high quality support. We won't be making any changes to our CFTs before they move into support. We're making changes to our support people before we start supporting them to make sure that if we say we support something, we really support it. It's an important part of our kind of whole F5 ethos is that you get world-class support with anything you buy from us. Speaking of buying, we offer 3 flexible license models: good, better, best, more features, more functions available in each of the thing. They're available in different throughput levels. They're available as a test drive for testing. They're available in the marketplace in the hourly standard, hourly billing, utility billing, and you can bring your own F5 license with you into the cloud. We like to think we give you the confidence, we give you the security, and we give you the agility that you're looking for in AWS. And we're an important part of lots of organizations' use of AWS, which brings me on to Alberta Motor Association. Talk about them quickly. They are, if anyone's been to Alberta, or rather I haven't been there, but I did Google their, I spent a bit of time on Wikipedia looking at the weather. It can be pretty cold up there and pretty snowy, and this is me sitting in a city that's freaking out about a ½ inch or 2 inches of snow tomorrow. You know, it's snowy, they have moose, there aren't many people per square kilometre, but AMA have 950,000 members. They made 450,000 assistance call-outs in 2015. They're a roadside assistance organisation, they're a road reporting, they're driver training, they're insurance and travel services. They're actually the biggest offerer of driver's ed in Canada, apparently. So, you know, they're a pretty important organisation. Obviously, to get their services, you have to do two things. You kind of have to give them some money, usually in the form of your credit card, and you have to give them some personal information. These are all things that people are out to get. Bad people out on the internet are out to find this information out. So AMA delivered a very robust, very good security solution in their on-premise data sites, using a lot of F5, using some other tools too, and you know, they had a very good, very robust security practice they were very happy with. And those are the kind of things that make AMA sort of AMA and unique. But there's some things that make them pretty much like a lot of other customers that we speak to. They're not moving fast enough for the rest of the business. So the web team wanted to get a project up, you know, in the standard thing. I'm sure this is probably familiar to a ton of people out there. The web team wanted to get a new service up. They ideally wanted to get the whole project done in about 6 to 8 weeks. The IT process time to get POs and get servers provisioned, not even maybe with operating systems and bolted in the rack and ready to, you know, start to be configured, was an 8 to 9 week process. So, you know, I'm sure this is a really familiar refrain that some of you out there will have heard before. I'm sure Nick's heard it plenty of times before, which is obviously this kind of problem that entirely drives people to using AWS. Quite rightly, because you can get stuff going in minutes, which is fantastic. You know, that agility reason is probably the primary driver for people using AWS. So, obvious solution to this problem. No time to provision manual servers. You know, this is the tipping point for them. But the exec team are concerned with security for the customer data that's going to be part of this application, and the IT team are concerned as well. So, you know, we've got these two conflicting factors. I need robust security. I need to be sure that I have robust security. They weren't necessarily doubting that they could provide robust security in AWS. More the fact that could they assure themselves of that security in the project timeframes? Probably not. But the web team still wanted to deliver their application on time and on budget. So you know, the solution they came to was a fairly obvious one. Or it would be to everyone at F5 would be, okay, we'll take your F5 stuff with you. Take your F5 security configuration with you to the cloud. You know, so you can pay as you go. You don't have to buy a license. If this whole application doesn't pan out, you know, obviously you don't pay. You know, you can pull down your application server, stop paying for them. You can stop paying for your F5 stuff. They were able to basically build their servers and their web environment in AWS. That's not, you know, lots of people are doing that. It's fairly bread and butter to do. They were able to take their F5 security policies, including their web application firewall security policies, and put those in AWS as well. So they ended up with the best of both worlds. They ended up with the security and the assurance that the exec team and the IT security team were looking for, but they could deliver the project for the web team on time. And then they were using familiar tools as well. So there wasn't no huge retraining. Obviously they had to get the hang of AWS, but they didn't have to learn a bunch of new security products. They didn't have to do a load of new auditing capabilities. They were able to use things they were familiar with, that they knew worked, that had done very well for them over the last few years in AWS, with a pay-as-you-go option. So very low risk. So low risk because there was no huge retraining, not a massive investment in extra knowledge acquisition, not a huge investment in necessarily in buying F5 licenses or buying servers, but just in in getting stuff up and running, seeing if it works, and being able to tear it down if it didn't. So again, they deployed Big IP Local Traffic Manager to load balance the traffic between their AWS and their availability zones. Used Application Security Manager, which is the web application firewall. I've tried quite hard not to talk about too many F5 product names in here because they do get rather long and hard to remember. But they basically built the same thing they had using LTM and ASM in Amazon. They were able to replicate what they had on site. You know, they've been able to decrease their workload. They've been able to. They're looking at now being able to self-provision for the web team. So that's the next step for most people that have done this, is to build self-provisioning. If you have things like CloudFormation templates, you have F5 templates available. You have, you know, the full API. Delivering self-service on a big IP isn't too difficult. We've got lots of customers that are doing that at the moment, using a variety of tools to do it. We can pretty much always find a nice way of doing it for you. They're able to deliver on the same on-premise security, and they were able to ease their transition into the cloud. And that's what we're seeing people are asking us most for at the moment, is like, how can you help me get there? How can you help me get my existing stuff, or, you know, a slight refactor of my application into the cloud with the security, with the stability that I've come to expect from the data center? And that's what we're seeing a lot of F5 customers asking for, and what we're spending a lot of our time doing, and making sure that it works nicely for them. And that's pretty much it. I think we've got, 15 minutes left for Q&A. And we're obviously, Nick and I are here to take questions. Thank you very much.
Cool deal. Looks like we've opened up polls here, so if you guys want to fill that out while we're going through questions, we can go through some of the details here. So, let's see here. We have some good questions coming in, so if you guys were probably reading some of the Q&A as we were going through the session. Again, the slides and the recording should be sent out after this call. There was a question around, let me get the exact question pulled up for you, basically on the difference between version 11 and version 12 for F5s and AWS.
Yeah. Okay, yes, so you do want to be on version 12 for cloud. In terms of major differences for enabling cloud platform services, if you're used to a big IP version 11, version 12 it brings new features. It brings better AWS integration. It brings more support for some of the cross AZ HA capability. If you will have no problems running version 12 if you're used to version 11. I don't think there were any significant changes in terms of. So for those of you that the person that's asking the question, obviously Steve, has a bit of F5 experience. So I'll maybe say some things that are beyond basics, and if you're not an F5 customer, you know nothing about F5, then forgive me. But there are. If you're looking to port existing configurations from version 11 to version 12, there may be some iRule stuff you need to look at. We do now have some upgraded advisor capability. If you're using the iHealth configuration health checker, you can run through that and do some basic health checks. Pretty much everything else is going to work as expected. You also get some of the iRule and IAP LX capability enhancements as well. But I don't think you'd have any problems running version 12.
Okay, and then there was a question about the high availability and kind of exactly what that means. I don't know if you want to deep dive a little bit into what high availability means, or what use cases you see customers using that for.
Okay, so high availability works in AWS very broadly the same way it works in a non-AWS environment on any other platform. Insofar as how we monitor the devices and how we decide to do a failover. So you will run a number of, let's pick a basic pair running together. They don't have to be pure HA active passive. We can do active active. Most people, when they're moving in, are looking for to replicate their internal environments, which are often still running active-passive, which is probably still the most common deployment. So essentially the two devices will sit, usually one in AZ, and each AZ, and will communicate with each other with a heartbeat between them, and will configuration sync. When you make a change on one, you can sync that configuration to the other. You don't have to, actually. You can make a change, test it, make sure it's working, and then sync it, or you can optionally sync it automatically. So there's a heartbeat that goes between the devices. When one stops responding to the heartbeat, and you will usually run this in a couple of different routes as well. When the heartbeat goes away, the surviving device will make a call to Amazon to remap the elastic IP, which is how we would have had traffic coming into the device, to the new device. So all the existing all the existing stuff that makes a big IP failover happen is exactly the same. In a physical environment, we'll do something slightly different because we have control of layer 2. In a virtual environment, we will map the elastic IP to the surviving or the new device. It's pretty simple. It works very reliably. Haven't seen any problems with it. Okay, any more questions?
Cool. There was a question on how difficult it was to upgrade from 11 to 12.
It's pretty easy to upgrade from version 11 to version 12. I would encourage everyone to use the Upgrade Advisor checker to make sure that their configuration upgrade is going to go smoothly. If anyone's familiar with the big IP upgrade process, it's exactly the same from 11 to 12 as it was from any other previous versions. In AWS, depending on what licensing feature you're using, you may be inclined to adapt a more cloud-like upgrade procedure, which will be certainly if you're using hourly billing and you're not using a permanent license, I will be tempted to just deploy a new one, copy the config over, and then just remap the elastic IP to the new one once you're sure it's working. The treat servers like cattle, not like pets mantra that you seem to see in the cloud can definitely be applied in certain circumstances to big IPs as well, especially if you're using a CloudFormation template to deploy. So adapt the CFT to use the newer image, test it, deploy the new image, and then just remap the IP and shut down the old one. But you can treat it as if it were a big IP in your data center and do an upgrade too. You need to make sure that you've given yourself enough disk space. If you go for there's a big IP solution on our support site that lets you know what happens if the various amounts of disk you can obtain. If you use the very, very smallest possible amount of disk space, there's no additional space to throw in the next image to boot the big IP into. So just be careful of that.
And I think there might be issues if you're on the hourly marketplace with that as well. I think if you're on the hourly marketplace, you may need to just start with a new instance as well.
Yeah, you'd need to start with a new instance if you're on hourly.
Let's see here. There was a question on, does AWS have tools to manage multiple AWS instances? The answer is yes. There's an abundance of ways, right? So if you're more of a DevOps kind of guy, you can use the Puppet, Chef, SaltStack, Ansibles of the world to do centralized management. We've got a number of services ourselves, whether that's things like, you can even do it with CloudFormation, you could do it with, some of our code, we call them the code star services, code commit, code deploy, code build. If you wanted something to do it in a more packaged environment, you could do things like Elastic Beanstalk. If you're in the container world, you can use the Elastic Container Service or ECS. So there's a plethora of ways to manage multiple AWS instances centrally inside AWS, and it really just depends on what flavor you want. If it's Windows, you can do all types of Windows automation. There's the something we call the EC2 run command, which allows you to basically run OS or kind of shell level commands across lots of instances at once. So that's kind of a very deep topic, which we won't get into too much. But there's a lot of resources out there, especially my favorite place to go look for just general AWS information is the reInvent videos, especially since it just ended. It's all super up to date, super in depth. and there's lots of resources out there. There's another similar question around security in terms of security best practices. Security on AWS it's a wide and broad topic. There's a lot of different perspectives on it. The short story is a lot of people will do security differently on AWS, either because it's considered a new data center and people want kind of a higher level of security in AWS. And so they can do it differently. Like when you start automating everything, you start getting more secure because you get less complex, there's less people involved, there's less accidental errors, there's less things missed. And so just automation in general can add a lot of security to your environment. But then, there are also some, vendor or partner changes. So, F5's here, and F5 works well on AWS. So that's one of the ones you don't need to change out. But some of the things, especially around like if it requires network taps and some of the more network-centric security, sometimes you may need to reevaluate that and look at different ways to solve those problems, or if it actually is a hard requirement for your environment. Let's see here. There's a question on, is there any difference during HA failover on AWS? For instance, is there a sync state maintained across availability zones?
No, everything works the same. Sync states maintained. We can map. We can, the session table gets copied across. So the only thing that really changes is the mechanism to redirect the traffic at the front end in a failover environment.
Okay, and then you don't lose sessions on that failover, right?
No, it kind of depends what you've decided to do. You can set it up. So for HTTP, so things like persistence and sticky sessions, as you might call them, absolutely. If you've got long-lived Layer 4 sessions, there may be some more issues in a remapping environment. We will maintain session. I haven't tested it personally, but as far as I'm aware, it works. Most people in an HTTP environment just care about making sure that session persistence in terms of where we're sending traffic to at the back end works. Turning on long-lived TCP sessions can be important if you're doing other, like WebSockets or MQTT type stuff. But yeah, everything works as it does in physical.
Okay. And there was a question, can you implement IPI, Fraud Prevention Service, ASM, and web acceleration on AWS?
Yes. IPI, yes. ASM, web acceleration, absolutely. Fraud Prevention Service, I have not been asked that question before. I think so. I don't like to give definitive answers that I'm not completely 100% sure on. That's something maybe I can check, and I will get back to you, or we'll add notes to this. But yeah, everything else, essentially, just to be clear, the code line that runs in AWS is, to all intents and purposes, exactly the same code line that runs anywhere else in any other virtual or any other physical edition of the big IP. In fact, if you spin yourself up a big IP in AWS this afternoon for fun, jump on the thing. I challenge you to tell that you're on a device in Amazon. It's exactly the same, the code line, the features, the functionality. We've made some small tweaks to things like failover and obviously the cloud init type stuff and things that make us work in a AWS environment, but everything else is extremely the same.
Okay, and then there was a question about the wide IP feature in Route 53, how, I guess compare that to F5 GTM.
So obviously both Route 53 and GTM, the end result is the same insofar as they're DNS servers that respond with a flexible an IP address that can change depending on what's going on. I can't speak much for Route 53. It's not something I'm hugely familiar with. But you could definitely run GTM in AWS if you so desired. I think now that Route 53 is capable of monitoring non-AWS endpoints, that's an enhancement to Route 53. We would still be able to do slightly more complex, clever, or unusual DNS environments in response. More programmable in your response than something like Route 53. But as far as I understand it, the end result of a Route 53 and a GTM is very similar. We probably just give you a little bit more flexibility.
Yeah, I think that's what I've experienced and what I've seen as well. Route 53 is pretty simple to do basic TCP or HTTP health checks, but And the routing policies, you can kind of make them hierarchical, but I think there's still a lot more features there on the GTM from what I've been told by customers. Let's see here. I think that's the bulk of the questions here.
Oh.
As you see, how long we need to
question. Okay, there's a question there. Is the automation piece handled by iWorkflow? If so, is it able to do configuration backups or mostly for deployment templates? So thanks for that question, John. Unfortunately, the answer for most F5 things is it depends. You can do it either way. So we have CloudFormation templates, which are not using iWorkflow. They're using the native Amazon CFT capability. You could potentially run iWorkflow against a big IP in the AWS environment. iWorkflow can't start up a big IP instance in AWS at the moment. Something we're looking at. So iWorkflow is, and for those of you who don't know, iWorkflow is a workflow tool we have that will deploy the F5 templates onto F5 devices. It's a super powerful, quick way of getting complicated solutions up there. It would be able to do configuration backups. iWorkflow is mainly for deploying templates rather than configuration backups. We do have tools for that, and you can obviously write tools on the big IP that will dump configuration to an AWS environment as well if you need to. Yeah, iWorkflow is primarily a workflow management tool in terms of deploying F5 configurations. Okay, so we're at the top of the hour.
Yep, again, I want to thank everybody for joining our session today. Thank our presenters and panelists for all the great content. This time we'll go ahead and close down our session. Have a great day, and thanks for attending.